We'll start the presentation. What we're going to do today is first we're going to get a little bit of theory on the electronics parts, which is going to be the crash course. And then right after that, we're going to do some calculations to find out what's the resistor value that we need for RGB LEDs. If you take a look at here, I got 1,000 RGB LEDs, which is very hard to get a hand of around here. And each one is like $3 to $5. So there's a lot of money invested in this 1,000 of them. I ordered them from the factory, but these are some of the coolest things that you can get a hand of, because you can do all kinds of colors with this. Some of you may have this already on your kits, and if you don't, it's an awesome thing to get it. Because you're here today live, each one of you are going to get at least one of them. So, can you come and pass this out? Each one of you just grab a couple of this. Actually, grab one for right now, and then when we do more experiments, we'll do that.
Yes, one each person?
Yeah, one for each person, please. Last week, we did the Arduino, Introduction to Arduino, part 1. We talked a lot about the details of Arduino. There are thousands, not thousands, but I would say hundreds of videos on Arduino that you can go and look and see the introduction to the Arduino.
She says she wants to see a close-up of the LED.
Oh, close-up of the LED? Perfect, yeah. Any interaction we want to have as much as possible. This right here, can you see it? Can they see it?
Yeah, it's focused.
Focused? Awesome. And it's got 4 legs. We'll go into detail about this in a little bit. And we're going to light them up and all that. Thank you very much. Okay, so let me go ahead and start the Prezi. Prezi is a very awesome presentation software that I would suggest anybody that wants to upgrade from their PowerPoint, they can do it. And you'll see the power of it today. I've incorporated both videos and also schematics and drawings into this particular presentation. Before I get into the presentation though, there's going to be a lot of people that are going to be watching us, and they're going to be saying, what is this all about, where are you guys at, and so forth. So I would like to first introduce, for all those that are watching us from around the world and in Orlando, our Meetup page. Everything that we're doing is going to be announced in the Meetup page, and this is our Meetup page, which is Arduino, Electronics, 3D Printing, and Entrepreneurship. And we're here in Orlando, Florida, and we both have courses and workshops in Orlando and in Kissimmee. Right now we are at our Kissimmee location, and next week we're going to be in Orlando, and we're going to be at the Microsoft store in the Florida Mall. You guys been there before? We did one a couple of weeks ago, and we're going to be back there. We're advancing from little basics to medium to very, I would say, high-end and also more challenging projects this year than last year. Last year we did about 30 workshops. Most meetups only meet like once a month, so they only do 12 a month. We did triple that amount, and we started back in March. The goal is to do one meetup workshop every week for every month. And the plan so far is to do two meetups in Kissimmee and 2 meetups in the Orlando area. And the most basic ones we're going to start in Kissimmee, and we're going to build up to the more advanced in the Orlando area. Any questions? Any questions from the audience? And do you see anybody asking any questions? Okay. How many people do we have online?
2.
2. Excellent. Okay. So Arduino Electronics 3D Printing and Entrepreneurship, and we're in Orlando, Florida. And if you want to join us, just go to meetup.com and hit the join button, and you'll be able to get in there. Okay, let's start. I have a presentation here about LED lights in a lot of detail, and I think this is going to give you, each one of you, a very close look into the power of LED lights and what it's all about, and into the power of the Arduino board. The Arduino is a microcontroller, as you've seen before, and for those that are new, it's a small microcontroller. It costs anywhere from like $25 to $30. Very affordable, but it's very powerful in the sense that you can connect things and control them. Things such as LED lights, motors, sensors, and really interact with the world around you. And what makes an Arduino board great, as we mentioned last week, is that this is the Arduino board. Let me unplug this real quick. Is that there's not only a board that is easy to access through these connectors, these headers, but also there's tons of code online, and that code is available to a lot of people, and you can look at the code and learn from others that have programmed this, and maybe copy and then modify it and make your own code, and it's open source. It's an awesome platform, an awesome starting basis to do robotics, to do all kinds of very nice and interesting projects. Okay, so let's go ahead and look at the presentation and see the LED lights, because we'll be using this Arduino board to control LED lights coming up next. And the type of LED lights that we're going to use is RGB, which is red, blue, and green. All three LEDs in one little unit, right here. Okay. Any questions so far? So far, so good? Okay. There we go. Last week we talked about an LED light. This is a simple one that only has one anode and one cathode, and basically it has a positive and a negative side. If you take a look at the RGB LED, we have 4 legs. It's much bigger than this one. It's because inside here we have several LEDs put together. So this is the symbol of just one single one that I have here. Imagine having 3 of those. That's what we have inside one of these. One red, one blue, and one green. And here is a close-up of it. There's 2 types of RGB LEDs. This could be very confusing for some people, because you go to the store and you just ask them, can I buy do you have any RGB LEDs? He goes, yeah, sure, here they are. You buy them and you realize you bought the wrong kind, or it hooks up differently, connects differently. So make sure that you get the correct RGB for your project. And there's one that's called common anode. Sorry, just time on this side. Okay, one is called common anode, and it looks like this. And then there is common cathode, and it looks like this. Now, can anybody tell me what's the difference? They look pretty much the same by the look of it. But what's the difference between common anode and common cathode? Yes?
The long pin versus what is referred to as the anvil, and that's the positive versus the negative. So if polarity is everything, polarity is everything.
Right. If you take a look at right here, the drawing, this long leg on the common anode is the common anode. As opposed to the common cathode, the long leg, as I'm showing right here, is the common cathode. So one is an anode, one is a cathode. And it matters a lot when you have to talk about how you're going to connect this. For example, right here I have a little detail. Common anode, the positive is connected to the power supply. The other legs, RGB, to ground. So this one, the positive is connected to the power supply, so you only need one resistor right here, and the other ones go to ground to turn this RGB LED on. So you only need one resistor on the positive, which is this big leg. Okay, that's on the common anode. Everybody got that? One resistor on the big leg that connects to positive. This other one, you need 3 resistors on the smaller legs, and this long leg connects to ground. So it's like almost the opposite, totally opposite. Here the big leg goes to positive with one resistor. Here the big leg goes to ground with no resistor. Okay? And then these other legs on the cathode have to have resistance because these are going to positive. Every time you go to positive, and I'm going to go and draw it right here so you can get an idea. This is going to be the positive and the negative, and this is going to be the resistor. Hopefully you guys can see here. You cannot connect LED directly to power because it would have infinite current and it would overheat and it would get damaged. So whenever you're connecting an LED, let's say this is the battery, this is the positive side of the battery, this is the negative side of the battery, and you're going to be connecting this to an LED. It's going to be right here. You need to make sure that you put a resistor on the positive side. And I'm gonna, this is a resistor. And then you can put your LED here. And I'm gonna put the LED in just a second as soon as we go through the chart. So this is the positive, this is the negative, and on the positive side, you gotta have a resistor that limits the current that's going into your LED. So we're going to figure out what value, what resistor value we need here in a little bit. And then I'm going to draw the correct LED that goes in there in a second. So it's very important that you know that, otherwise you'll be blowing your LEDs and they will not work for a while. So let's take a look with more details. Here is a little bit of a schematic of the common anode and common cathode. This is what we're looking at actually. It'll become more apparent to you when you connect this into your Arduino board. Which of these two do you think we can connect? Let me go back to this. Which of these two do you think we can connect to the Arduino board? Can we connect a common anode or a common cathode? Which one of these will work? One of them will work better than the other, or one will work, the other one may not even work. What do you think?
Technically, you can make both of them work, but it was a matter of what do you got to do. In fact, not to confuse anybody, it is the fact that you can even take that part that's the common cathode that would go to ground, and you could actually hide the resistor in there, because as long as it's somewhere in the circuit to limit that current, you're good.
Yes. But if you want to have total control of the Arduino board, which of these two would you use? Would you use the one that you just need one resistor right here? Or would you use the one that you need resistors on each one of these positive, I would call them power lines?
3 resistors.
3 resistors, that is correct.
More configurations.
Yes.
And is that the cathode?
This is the common cathode. That is correct. So what we're going to use, we're going to use the common cathode. We're going to tie each one of these legs into a digital pin that is going to create pulse width modulation. First, we're going to turn them on and off. And we're going to control each of the colors. So we're going to need 3 resistors. Very nice.
I have a question. How can you tell which one you have by just looking at it? Can
Well, it's hard to tell them by just the look. You got to look at the spec sheet when you bought it. And if you have it, you can just test it out. Put a resistor and see how it lights up. Once you know how it lights up, then you'll say, oh, okay, I have a common anode or a common cathode. There's not a little C or an I, but if you look inside, you can see how the pins are. But this one is hard to see because it's not transparent. This one has a diffuser, so all the colors blend in. There's other ones that they sell that they are transparent, and you can see by how they're connected which one is which. In this case, it's kind of hard to see in this picture,
Yes.
even if it's
I can
see-through,
tell.
because everything looks the same pretty much. But you could see the connection inside if you could see it through. Okay, so this is what we're going to connect in a little bit. You know how it looks, the legs, and so forth. We have a common cathode. So we're going to connect and light up a basic LED. We did that last week. We're going to do number 2 today. We're going to connect and light up an RGB LED. And we're going to hopefully use pulse width modulation as well to dim it, or make it brighter. That would be the ultimate thing to do today. All right, so let's go ahead and take a look at some stuff that you can do with the LEDs. I have some videos here that I want to show you. Can you ask, is there anybody that is watching on Periscope that has any questions so far? We're going to start showing some videos. Can you guys hear well? Please type something, a message, and Paulie, my cameraman, will be able to see it.
Polly.
Okay, if you get any messages, let me know. Here, let's take a look at this video. What some people do, and this is in South America. People create all these amazing ceilings, and they put RGB LED strips of LED lights. And let me show you, I'm gonna fast forward here. They're installing this, and you're gonna see the result in a couple seconds when they light them up. And they're hiding right behind there. See how the ceiling, they can create all these different moods and colors in the whole room just with RGB LED strips. Pretty awesome. Imagine having some of this in your room and changing the colors for whatever mood you feel like. Or it could be an alarm, connected to an alarm that wakes you up in the morning with music, and then the light just changes. Pretty nice and interesting. All that with microcontrollers. In this case, they're using rows of LED lights that are in there. Okay, let me pause on this one. I have a couple more to show you of some of the projects. This guy is in South America, and he makes those are the LED RGB strips, and he makes this sound that they respond to sound, and these are for clubs or areas. So you can even have this in your room. And let me show you, showing you how it looks. You're using an acrylic type of a makeup, and you can change the colors, and they go to the beat of the music, and they can change to them. Pretty cool to have at a club. So you can change them based on the beat. This would be like an equalizer type of thing. And then explain. So there's tons of projects similar to this. Let's take a look at some other applications right here. This one is the same guy. I'm putting it in a disc and moving a disc with a motor. He just cut up a part of the disc, and now he's going to spin them and change the colors. See how it's turning? It's creating different colors. He just got a CD player, made a cut, put a light underneath, and creating all these awesome colors and stuff like that. And you can make this go to the beat of the music, however you like to as well. And that's using a motor and so forth. Now let's take a look at a couple other projects. This one is pretty nice. change the whole color of your room by creating something like this. Right behind each of those panels, there's an RGB LED. Incredible change in color and control of color.
What's wrong color?
This would be nice at a restaurant maybe, people waiting or just relaxing, or a lobby. Or you could put a logo in front of it, company's name. You could have your own business just doing that. Okay, let's take a look at a couple more applications. See one of those. Let's take a look at this one. You have a car or a motorcycle, you want it to go at night? You can make it look, change the color of it, how you like it. Alright, so a lot of applications, these are using mainly strips, but it's all starting from the same point of this RGB LED. Two more. Alright, very nice and crazy, but you can do almost anything. They incorporated a motor, an RGB LED spinning fast, and our last video of applications. Very nice. Those lights not only lighting up, but they're moving. In this case, they only used a couple of hues of the blue. But imagine the tone control that you can have once you can move and change the colors of red, green, and blue. Okay, so to complete our circuit right here, I'm going to go ahead and write the symbol of the here so you guys can see it. Here we have the resistor and the LED. In this case, we have three different LEDs. So we're going to have three resistors. There's another one. And three LEDs. We're going to have a red LED, a green, and a blue LED. This is basically the circuit that we're going to create. 3 resistors, and each one of these is a leg of that RGB. And then one of the legs connects to negative, the extra leg of the RGB LED. And the power is going to be given by the microcontroller. So instead of using a battery and just these 3, if I were to do just this will light up, these LEDs will light up, but you wouldn't have much control over them. They would just be steady on, and that's it. So if I want to do anything to control the brightness of these LEDs, I have to have a microcontroller that will control the supply and the pulse to this. So right here, I'm just going to put a box. This box is going to be the Arduino. Is going to control this. But instead of having one pin, you're going to have 3 pins connected to the Arduino. Each one controlling one light, one separate light. So 3 pins are going to control that from the Arduino, and then all the negatives are going to go to the same common ground in the Arduino, and we're going to define which of these 3 pins we're going to use to turn on or off. And we can turn on and off at different rates, different pulses, and make them brighter or dimmer. And all this combination will give us the different hues and different colors. So basically this is our circuit that we're going to create. But before we do that, we need to figure out what value are these resistors going to be. The Arduino will give out 5 volts on each of these legs maximum, and this particular LED has certain characteristics that we need to use to figure out the resistance value. The resistor is rated in ohms, so we need to find out how many ohms we need on these particular ones. So let's go ahead and take a look at some of the formulas, some of the calculations that we need to do. And this basic algebra, I created a calculator on Excel for us to do this. I'm going to open up that calculator, and with the calculator it's very easy, but we're going to go over the formula of it. And once we go through the formula, we'll be able to see exactly what we need to do. I'm going to put this calculator up so you can kind of understand, and I'm going to go over the calculation right here. If you want to follow me and get a piece of paper and pen, that way you can do your own calculations. It'll be better for you. That way you'll be able to follow it and you'll know for sure. Okay, so this is a current limiting resistor calculations for RGB LEDs. If we look at the specs of this RGB LED, it tells us that we need 2 volts on the red pin to work. The green needs 3.3, the blue needs 3.3. These are what is the voltage LED drop that is required for it to work. If we have a power supply of 4.5, in this case it's going to be 5 volts because coming from the Arduino, so I'm going to change that to 5 volts. Look how the resistance value changes at the end. It changes because I have a formula right there. So if I put 5 volts, these are the resistors values that we needed. Very simple. Now let's go ahead and do this on paper. In other words, do it right here on the board so you guys can see it. Basically what we have is a power supply. We'll do the calculation for one of them, and then the rest will be very easy it will be very easy for us to do. Move this out of the way. Okay. So the formula is, we basically need the voltage of the supply minus the voltage forward we need to calculate that difference, and then this is going to be divided by the current, the forward current. So this comes from, current is abbreviated with I, so V equals IR. That's the basic formula, and we need to find the R. So if this is an algebraic expression, we need to isolate the R, so V divided by I is equal to R. This is what we're using right now. This is Kirchhoff's voltage law. Very simple. This voltage though is that difference that we have right here. The supply minus the forward voltage. That's this voltage. And the I, which is the current. Now these values, all of these values comes from the spec sheets of the manufacturer that created these RGB LEDs. So in this case, I'll put right here what the specs are. In this case, the red.
She says, how was the current calculated again?
Okay. Well, we're not calculating the current, we're calculating the resistance. This is the formula right here, and I'll put it up here. V equals IR. Voltage equals current times resistance. Okay? Right now we're trying to find out what the R is. What is R? We know already the voltage and we know the current that will make that LED light up. So for that LED to light up, they have given us the following specs. In this case, I'm just going to draw one LED out of the three. They're telling us that for the red to work, based on the, as you can see in the calculator, we need 2 volts.
She says, where did the current value come from?
Comes from the specs of the RGB LED. So this RGB was made to work with 2 volts and it has to work with a current of 0.050. Let's take a look here. Let me expand the calculator in amps. So 50 milliamps. This is amps. This was given to us, I'll put here given. This was given to us by the manufacturer to work. So this is the voltage. And this is the current. Let me erase this so you guys can see it. Okay.
John Paul, question.
Yes.
On the green and the blue, the 3.5 plus the 1.5 equals the 5. But on the red, the 2.5 plus just 2 does not equal 5.
Let's
Is
see
there
here.
something with that?
We have 5 voltage 2. Oh yeah. Let me see. There must be a problem with the formula here. Okay, that one works. That is correct. Let's take a look at this. It should be 3, right?
Yeah.
Okay. Yeah, I didn't put a formula there. I just wrote that.
Yeah.
So this needs to be 5
Minus 2 equals.
equal this cell minus that cell. That is correct. Thank you very much. Okay. So this information was given to us. all this by the manufacturer. And it's telling us for this LED to light up and not to heat up and not to blow up or burn, it needs a 2-volt forward voltage and needs to work on 50 amps, 0.050 amps of current. This is the same as saying 50 milliamps. But in our formula, everything has to be in the correct units. Volts have to be in volts, current has to be in amps, and resistance in ohms. So that's why when somebody says, oh, 50 milliamps, we need to convert it to amps by putting a 0 in front of it and a period. That's what it is. 50 milliamps is this. 60 milliamps would be, get it? Very easy, right?
I have a question.
Yes.
So 5 volts comes out of the digital outputs, right? Like with the Zeldas?
That's right. 5 volts coming out of the digital output of the Arduino,
Okay.
and that's our supply voltage. So right now, just like you mentioned, I'm going to put here the 5 volts that's coming out of the Arduino, right here. The voltage forward is these 2 volts, and the current 0.050. 50 milliamps. So what's happening basically is this. Let me just draw it here. Here you have a resistor, and here you have your LED. Let me do it in a different color so you can see it a little bit better. Those are in series.
What if we use the analog outputs when you see the correct voltage?
The analog will not work to create the dimming effect that we're trying to achieve because we're using pulse width modulation, and I'll explain later on what pulse width modulation is.
Okay.
But we're using the digital, and we're making the digital pulse and simulate something like the analog.
I see.
Yes, so that's what we will be doing. But right now, we're trying to figure out the value of this resistor. We already have it by the calculator, but I want you to see it so you can understand. So basically, you have a 5-volt supply right here coming to this circuit, and this needs to dissipate some of the voltage. The voltage needs to drop. So across here, we're going to drop out minus 3 volts. I'm not going to put minus, but 3 are going to drop out here and here. If 3 volts are dropped out by this resistor, then what we have? 2 left. Across here. And that's the 5. So in other words, for this to work, we need to drop out 3 volts out of here. So that's what we're doing here. 5 minus 2 is 3 volts. We're dropping out 3 with the resistor, and that's going to create only 2 volt drop here, and it's going to limit the current. So if I were to put, let's test you guys out. Looks very simple, right? Let's test you guys out. If I were to make this 10 volts, and you know that you need 2 volts here to work, how much voltage drop we need here for this to work? I'm starting with 10 volt supply.
8.
We need 8, that's correct. So we need, he's running out of okay. So we need 8 volts. When you get a 9 volt battery, right here, we need 7. That's correct. 7 to drop out, so we can have 2 working here. If we overdo this, then this will burn out. Very simple, right? So far, everybody understands. Any questions from anybody in Periscope? Okay. So we already done the calculation with our calculator. For the red, we have 5 volt supply coming from the Arduino. We need a 2 voltage LED drop. So the voltage drop across the limiting resistor is 3. There's 5 volts, 3 drop, we get 2. For that to happen, we need to have, and this is the forward current that we need to work in there, we need 60 ohm resistor. So that's the value that we need to find for the red. For the green, we need a 50 ohm resistor. And for the blue, we need another 50 ohm resistor. Okay? So those are the 3 resistors that we need. I have a bag full of resistors right here. Bags. It's a bag. And we need to find those 3. So, can you guys take a look in your computer, do a little research right now on Google, and see and tell me what color. I'm going to go to what color of a resistor I need. If you notice the resistors, they have several bands around them, and based on the band, you can tell what value they are. So for example, let me get these ones out. I have all these resistors in here. I'm going to get one out. And these ones have colors around them. And the colors tells us what's the resistance, how many ohms there this has the value. In the case of this one, I have a brown, black, yellow with a gold at the end. The one at the end, the gold, tells you the tolerance, how accurate it is by a percentage. The brown and the black and the yellow tells you how many ohms there is in the value of this resistor. So look on Google and see if you can find the chart and tell me what 3 colors make up a 60 ohm resistor. Let's start with the 60 ohm. I'll go ahead and look for the chart, and we'll go over that chart right now. Resistor value chart. Let's see what we come up with. There we go. Let's take a look at this one. It looks more comprehensive. Let's see if we can get a better. There we go. So there's different types of resistors. There's some that have 4 bands, 5 bands, and so forth. So in the case of the 60 ohms that we need, what color is equivalent to 6?
Blue.
Blue. So in our resistor, let's say this is our resistor right here. First one we need is a blue. What do we need next? Brown? Or black?
Black.
Black. If it's brown, it would be a 1. Blue, black.
Oh, because that's for the first 3 bands.
Oh, all of them black is 0. Either a 3rd digit, 2nd digit, okay. And then, that's it, right? And then the last one will have to be something of a multiplier.
Brown.
If it's a brown, it would be a 600 and
Yeah.
601.
You
So
need a
what
black.
would be the solution there?
Black. Multiplying times 1.
Exactly, a black. So we need, and the tolerance will be the last one, times 1, which is 60. Blue, black, black. Let's take a look. There are other very interesting let's see, resistor calculator. All these awesome tools that are out there. I'm going to take a look. Let's close that up. There's a resistor calculator right there. Six. What's the other one?
Zero.
Zero.
One.
One. What does it say down here? 60 ohm. How beautiful. Life is so much easier with a computer. So if you didn't know, that's exactly what we need. And in this case, this tolerance is the gold, and the gold is 5%. If you get a resistor that has a gold band, that means it's very accurate. That means on 60, we'll be within 5% of 60, the value. So you will not get exactly 60, you'll get a little bit less than 60. And you can do your own calculation, how much would that be. So that's what we need to find. So the challenge right now is for you. I'm going to pass this on. I'm going to give you different bags. Some of them are already labeled, some of them are not. And for you guys to find blue, black, black. So. Blue, black, black. Better looking. Blue, black, black. Wow. And keep them nice and neat if you don't mind. That way, you guys here share this. Because we're going to put them back. So whoever finds the blue, black, black, the first, let us know.
Are we gonna learn how to do this in Fritzing? See the video?
Yes.
Awesome.
While you guys are doing that, I'm going to open FreeSync, which is one of the tools that I emailed you guys that we'll be using, and I'll create the circuit that we're going to connect today. How many of you downloaded FreeSync since last time? You have it? Excellent. If you haven't, it's a very awesome tool that you can use. So while you guys look at that, I'm going to go ahead and open up a FreeSync.
We found one of them.
Oh, you found one? Just one?
Well, out of that set, you have between a green, black, black, and a blue, black, black. We have one.
You have one? How many you got there? 10?
Well, I found one that had black, black.
Yeah, it's brown.
Oh, it's brown,
That's
okay.
10.
See if you can find blue, black, black. That's what we're looking at.
But of all the other
While you guys do that, I'll
combinations,
open up
black, black.
FreeSync. And,
Or green, black, black. Because one is green, black, black too.
well, it's green, black, black.
50.
50? Okay. Yeah, keep that one.
But it was a brown, black, black, so it's not even that.
Oh,
Either.
Well, you can put them in series and make.
yeah, we
Make
can
it
do
up,
series
sure.
as well. That is
Yeah.
correct. Okay, so we're loading FreeSync, and here we're going to draw our schematic.
I knew it was a black, black.
So this is a program to do schematics?
This one does schematics, breadboard schematics, PCB, and you can also write the code in there.
So it's called FreeSync?
FreeSync, very, very nice, awesome software. Can you put it in? All right. So we're going to go to the breadboard here. Our breadboard is a little bit smaller, and here on the breadboard you can choose the components that you're going to go ahead and add in there. This is a full breadboard. If you look at the size, I'm going to reduce it to a half. That's more like the one I have with me. But now there's a half plus, and that has the coloring on the bands right here. If you take a look at mine, I have a blue and a red, a blue and a red. So this is the exact breadboard that I have in my hand drawn right here. Very nice and clear. Okay? Now let me show you a couple things. You can move this around wherever you're going to place it. The next thing I need is maybe what I'll do is I'll rotate this. I'm right clicking and I'm going to rotate 90 degrees clockwise. There we go. Rather vertically like this. Now I'm going to put right here an Arduino board, and under 4 parts I'm going to look for an Arduino board. I'm not sure how fast this is going. Let me take a look. See, Intel. This is the symbol for Arduino, and now all the Arduino boards are being loaded into here that exist in
How
there.
did you shrink the resolution?
The breadboard, right here, there's a little tab which says size. I put that half plus on the bottom. You see on the bottom, you have breadboard 1, properties,
Yeah.
size, half plus.
Oh, I see it. Thank you.
No problem. Okay, so here are my Arduino boards. I have the Uno revision 3, that's the one I need. So I drag it, and it's right there. This is the same exact thing I have here in my hand, being drawn in FreeSync. My breadboard and my Arduino Uno. Pretty cool. So now, I'm going to connect, but I'm going to rotate my Arduino Uno so that I can have the pins that I need. So I need something like this, my digital pins, which are right here on this side. So I'm going to right click here, rotate counterclockwise 90 degrees. Boom, right there. You see that? Very nice. I'm going to connect to these pins 9, 10, and 11. You see that squiggly line right here? I'm going to zoom in. These are pulse width modulation digital pins. These pins are digital and they can create pulse width modulation, and that's what I need for what we're going to do on the second part of today. Hopefully we'll get to that part. Okay, so let me zoom out, move everything a little bit here, a little bit there. So now let me go ahead and find the RGB LED in here and see if we can find that under search. RGB LED. There we go. We have several of them. Common cathode. What a luck. We found the correct one right here. I'm going to drag that right here. I'm going to rotate that clockwise. There we go. And I'm going to plug this in somewhere around here. Look what happens when I plug that in. Let me move that a little bit more. When that's plugged in, all these pins that are plugged into there are lit up. Let me take a look at this other one here. 6 legs, common anode. Okay, what about this? Common cathode. I'm not sure why this is not clicking. Usually these go inside the pins right here. I'm going to see if I can find another and see if there's any major difference in that.
No, you could always put it in wrong, as in put it in.
Yeah, I'm not sure why it's came off on the side.
That's fine. I like that.
It should actually go in there. Let me take a look. If the same thing happens with the other common anode. Okay, there we go. See what it is?
It won't go.
Yeah. It goes perfectly in this, like this, but if you connect them to the other side, let me rotate. Let's do 180. Okay. 90 degrees. Okay, so assume that these are in the holes. I'm not sure why it's not working on that way, because we need this to connect across. If we're going to put things across here. For example, this leg is connecting to all this. I'm going to zoom in here. This other leg is connecting to this line. This other leg is connecting to this line, but they're supposed to be inside the hole. And maybe the grate that we have is not, I think that's what it is. The grate that we have is not exactly doing anything, but it's okay. It'll still work. Let me check out the grate. Not the, everything is lining up. Let's see if we can pick up another bird. Okay. There we go.
That works.
That one works. Everything is lining up. It's a little bit different, probably a different manufacturer. Let's take a look here on the breadboard. They do the half plus. Okay, that's what it looks like. When we go just half, it works. When it's half plus, does not work. So, let's go back to just half. Make sure it lines up. There we go. And let's get rid of this one. Now, if we take a look at our RGB LED, we see that there's a long leg. Go ahead and get that leg, push it forward, and make like a little step, like that. The reason we're doing that is so we can denote that that's going to be the big long leg. Don't be afraid, you're not going to break anything. Just move it forward and just bend it a little bit. That's going to allow us to know that that is what's going to connect, that's the leg that's going to connect to ground in our board. So I'll go ahead and do that right here. And I'm going to put that right here, directly, and I'm going to open up this just a little bit so that it fits in there. Like this. 1, 2, 3 legs. One connected to ground. There we go. Okay. See if you guys can see that. The big leg is connected to the ground or the blue line all the way. And then the red and the other legs are connected to the lines. Okay? So I'm going to go ahead and pass this to you guys and you try to do the same thing. Okay? This is how it looks from the side. Got it? Perfect. Okay. So basically what we're doing is we're connecting one of the legs, the big leg, to the ground and the other ones there. I cannot do it in the drawing, but that's what we're trying to do. Let me go ahead and find the resistor. R1. Here the R1 resistor, we can go ahead and change the resistance and and change this to 60 ohms. See what happens. 60 ohms, it changed to the color. See how cool this is? Blue, black, black. So you can change the value right here at the bottom. And I'm going to go ahead and get 2 more resistors. Okay. Here it is. The next one. And 1 more. Let me take a look and see which of the legs is the one that I used for the RGB. You have, can I see that?
Yeah. You have your bottom one at 21. Let me borrow first and your top one at 18.
Okay, so it's the second leg. Based on this, is my second leg that's going to ground. Okay. Right? Yeah. That's the long leg, right? Okay. So that's correct the way this is. This leg is the one that's going to ground right here. So what I'm going to do is I'm going to put since I cannot bend the drawing, the leg on the drawing, I'm going to go ahead and put a connector right away from here to ground.
The longest leg, right?
Huh?
The longest leg.
You're going to make a little knee type like the one. So I'm going to make this black, change the color of this to black, so you know that that connects to ground. You don't have to put this if you already painted this leg and it's going to the blue line. The blue line is the negative line. So this is your leg bended and it's connected right there, but since we cannot bend the drawing, I'm connecting this directly to here. Like that. Okay? So far so good. Let's change the values of these resistors. Make sure we have the correct values. This one is supposed to be 60. We put 60. Pretty cool. Change the color. This one, gonna change to 60 as well.
So how do you know which leg is what color?
On the resistor, it doesn't matter.
On the specs? Or does it matter?
Doesn't matter. You can do
'cause
this
that's how you're
one
saying
way
it.
or another. That's a great question. The question was, does it matter which side you put the resistor? Either the blue on one side, and black, or the black, blue. It does not matter because resistors don't have a direction. They all have the same value. Basically, a resistor resists the current, the voltage. It helps us do it's a resistor. It resists the current, and it works with the voltage to drop it. That's the purpose of it. So in other words, it's not a perfect conductor. It has a value of how much conductance and resistance it has.
It's like a faucet.
Yeah, like a faucet,
It doesn't matter
enough
which way the
that you
water's
control
going.
how much the water is going through a pipe. Thank you. That's a
How
great
about on the
analogy.
LED though?
Huh?
Yeah, it's got
On the
the-
LED.
The LED does have a direction. If you take a look at here, I forgot to put the line here. The LED, the one that has the line is the negative, and this side is the positive. I'm going to do it with different colors so you guys can see it a little bit better. This is the positive side of the LED, and the other side is the negative side. And let me see I'll do it with this color. And this is pointing like an arrow going this way. If I put this backwards, it will not work. An LED is actually a diode. A diode controls the flow of current, so it can only go in one direction. If you think of this line as a wall, if you come in here and you get to a wall, you cannot pass through the wall. So if you put this backwards and you're trying to connect something going this way, you will not be able to do it because the way that the diode, the LED is made, the direction of current can only go one way, and it's the direction where it's pointing down. So basically, this is how our current is going, from positive to negative. A negative is abbreviated with this little symbol of ground. Big line, small, small, and smaller, which is different than the battery. So you guys don't get confused. The battery is like this: positive, round and big, smaller, like a triangle. So, very good question. The diode, which is the LEDs are considered a diode, only goes in one direction.
But on the
So a diode is used many times to control the direction. For example, if you have a device and you put the batteries backwards, they usually put a diode there to protect your device from opposite current. If you didn't have a diode, you could blow your device if you connect the batteries backwards.
There's a pattern.
So it blocks the current if you put it backwards going into the device. And that's very, very highly used in solar panels that are going into inverters and so forth. If you imagine putting the current, the voltage, hundreds of volts backwards into your inverter and other electronics that you need from a solar panel, and you just blow them.
Big ones.
So you need a very high value of a diode that protects it. Okay, so we have this so far. Let's go ahead and pick the pins that we're going to use. We're going to do 9, 10, and 11. So put a wire from 9 to there, from 10, somewhere in that line, and then 11. Right. I'm going to zoom in there and see. I'm not sure which one is the red, which one is the green and the blue. I'll just give them colors. Once we light it up, we're going to be able to see which one it is. So I'll go ahead and just change the color here from black to red. This is going to be green. Hopefully we have matched this, and this might be the bluest. Then the other thing we need is to put our power supply here. We need to connect the ground to the ground. Make that black. The 5 volts coming from here.
So John Paul, can we make a correction on here while we're at it, that the red has the different value?
Yeah, right now we're gonna just use the same values from the two. 10 ohms is not that much different. It's not gonna blow them.
Right.
So either we get a 50 or a 60 ohm. It does not matter. Did you guys find the resistors?
No.
You found 50?
I found the close one.
Okay. What values do you have? Do you have the 50 ones? 50 ohms?
That was the, oh, wait a minute.
I don't think so.
No? Well, yeah, have Dad look at that.
Let's take a look.
Because the other ones that we found were like brown, black. So they were like 10 ohms.
10 ohms.
I found a brown, black, silver.
Okay. Let's take a look. We don't have to be that close. I think many of the ones. Let's see. Oh, black. It looks like blue, gray, and black. Okay, let me take a look and see what I have here. Really quick, let's connect them. Maybe. Let's check it with an ohm meter. The other way you can check is with an ohm meter.
Got a 70. It's not 60 or 50.
You got 70?
Yeah.
Oh, pretty cool. 70 will work. Let's take a look. Let's double check it. Voltage. That. It's saying 0.
Oh, that's not working.
Meter may be acting up. Okay. Let me see if I have my other meter. Measuring it.
It's green, brown, black,
That's why
gold.
it's good to have another
51, right?
It's green, brown, black,
Is the one?
Black.
Chantal, is this 51, green, blue, and black?
Let me take a look.
Green
This
is
is
4. Wait, no.
460.
Green is
Which one, the
5,
one
yeah.
that you said?
If it's green, brown, black, it's 51. I mean, it's correct, but 50, right?
51. Pretty good.
Okay.
Exactly.
Oh, we have some.
Dad,
This is good.
that's 'cause they're saying 0.
That's 51. Go ahead and grab 3 of those.
Me?
And yeah, and we're gonna pass on to the rest.
Dad,
I'm gonna grab 2 and then pass it on so that way somebody else can use them.
Yeah, you can use that. No problem. Try those two. Okay, so what we're gonna do right here is we're gonna test these other ones and see if we can. That one is not working. We're gonna test it with here. We're gonna see if we can come up with something close to what we need. These are 100. Let's see.
oh, I think
128. This is huge.
this is not it. It was this one. Right? Oh yeah, this is the one. Dad, here, can you check this one?
Yeah, we're gonna check in a second. This is 300, and let me see this. Oh, this is good. This is 70. 70. Go ahead and give that to them so they can use it. To one of them, whoever wants to. Actually, let me get 3 of those real quick. Polly.
This is black, brown, yellow.
Okay. This is about 148. Let me get 3 of those. You need one.
I need 2. I need 3.
Picking these, you want
Oh, I can bend them. Yeah.
Okay, cool.
Yeah, I just slightly bended using the table.
So we're gonna find something that we can use. In this case, let me take a look at this one. Get a little bit close up here.
Move this over. These are nice thick wires. Here.
These are too huge. They're in the 500, 500,000. Let's try this other one right here.
All together. And then
Can you see what is being displayed there? These are about 148 ohms. Oh, that's awesome. Very nice and clear. I'm gonna use this for right now, even though it's not the exact, but I think it'll still work.
This row connected.
So you guys.
Oh, you'll move the light down.
I'm gonna give you these 3.
Alright, cool.
Those 3 will work for you.
I think it'll challenge you, so.
Another 3 here. These are 148. They will still work. They're close enough.
140.
Yeah. Instead of 50, it will still work for our purposes. So what we're gonna do is connect those, and I have something already here connected.
3 more?
Oh yes, right here. Let me double check this.
Yeah. It's okay. It's so small. It's not gonna come.
Yeah, choose 8, 9, and
Okay. Yeah, we have these 2 that are within the range that I think it will work. See if you can get some close-up of them connecting all that. Try these 2 for right now.
Yeah, these numbers
Oh,
are
here's
not gonna match. So 10 is gonna be 15.
All right, so you guys hurry up and please build that.
Actually,
We
we
got
can make
about
it
10 more
17.
minutes.
That way we can line this up with
So
it.
we're gonna get this going.
You mean 11 on 7?
So I connected my Arduino Uno, and now I'm gonna connect to pin 6, 7. What are they? 9, 10, and 11.
These are really tall.
I have the green on pin 10,
Hey, how much?
the blue on pin 9, and the red on pin 11. Can you get a close-up of this, please? So people can take a look. Okay, so I got my 3 wires connected and my ground. And let me take a look. My ground in my case is going directly to that pin where the big leg is. Now I'm going to go to the Arduino code. And we literally have 10 minutes to finish this because I know they're going to start closing soon at the library. But if you open your Arduino IDE, we're going to go to the same program as we did last week, the Blink program, and we're going to modify it. Or we can write a quick one here. Do a little close-up of here so people can see that. So here we have the ground going to the big leg. We have the red going to the other leg through this resistor, going to pin 11. The green, and I have the green wire just to match, is going to pin 10, and the blue to pin 9. So now what we're doing is basically sending the information through all these 3 wires, the voltages, going through the resistors to light up that LED.
Is there any way you can go back to that diagram you had?
Yeah, what I'll do is I'll put this here, and I'll put the diagram.
You know how to do it, right? You have the jumper.
This is the only part that you need, basically. I'm going to make this bigger.
So it's not work.
The resistor doesn't work.
Yeah, that's
We're going to go to examples, basics, Blink. This is the Blink program that we had last week, and we're going to modify this program. We don't need anything up here. It's basically comments, so we're going to delete. And right here is the basic part of the program. In this case, if you take a look, we're using pin 13, but we're going to modify it to pin 9. And we're going to add the other pins, 10 and 11, right here. So we have 3 pins, 9, and then we're going to do pin 10 and pin 11 as being outputs. So we have initialized pins 9, 10, and pins 11. Can you put a little bit zoom in into the code of what we're doing? And we have made those outputs. And here we're going to do pin 9 as being high. Pin 10. And there's a little delay here. And here I'm going to go ahead and add another 2.
Still it's not
So you know these are all different voltages.
Still it's not work.
So basically we're tripling the stuff that we did last week, and we're going to make all of them high so that the 5 pins are being sent out.
No, you can't do that. Because
High.
I'm gonna take a picture of that so you
And
can see
another
it.
one high.
I'm fine. I know how to see it. I know how to do it.
That's it. So right now we're turning all of them on, and it should be a white light when that
Doesn't
happens.
fit in
So let me go ahead and make sure I'm connected to my board on port 6. I'm using the Arduino
No, you're not
Uno.
connecting it right.
I'm going to go ahead and test out, see if this works. So far the compiling is happening. Can you zoom in please right here? I'm about to light up the LED. Okay, zoom in right here. The compiling is being done. There are no errors. So basically I'm setting pin 9 to an output, pin 10 to an output, and pin mode 11 to an output, and then with the digital right, I'm turning those on. So when I go ahead and load this, it should send the signals, and that should turn on to a white light. Right now it's uploading. We see the little blinking lights. It has lit up, and that's supposed to be kind of like white, but it's kind of a little bit off. So right now I'm going to turn on pin 9. I'm going to make that a comment. And pin 10, and I'm going to go ahead and resend it, and it should change the color to just one color. Red. So right now, if you take a look, Juan Pablo, is this being zoomed in?
Yes, the red line.
Right now, if you take a look, pin 11 is supposed to be red. And let's take a look. Hey, we matched it. It's perfect. Pin 11 here is being sent out and it's turning red. Now I'm going to go ahead and turn off the red color,
Yes, it is.
which is pin 11,
Correct.
and I'm going to turn on the other color, pin 10, and see what happens. I'm going to load the new program, and now it's green. And we matched it. Pin 10, we turned that on, it's green. Now I'm going to turn off pin 11. I'm sorry, pin 9. I'm going to turn that on. And I'm going to turn off pin 10. And I'm going to send it. And that should turn out to be blue. Beautiful. So see how amazing this is? We have 3 LEDs inside that LED. A red, a green, and a blue. And now we can change the hues of them and create almost any color in the rainbow that there is. Okay, what I did is,
You commented out.
I commented out the red and the, let's see, let's go ahead and let me put the names of it. 11 is red. So 11, I'm going to turn the red
No, that's mine. That's mine.
LED. Yep. And then 10 is green. And then 9 is the blue.
Wow, I found it.
So as you can see, we have changed the colors of the RGB LED. Now to make them dim, we have to write a program that will go ahead and change the pulses that are going into there. We don't have enough time to do it this time. We'll do it on our next week as the starting part of the workshop. Any questions, anybody, so far? Yes, Polly?
How does how does the LED work? Like, how does it light up?
How does it light up? Very simply. Great question. We have 5 volts coming out of the blue wire, going to the resistor, dropping those 5 volts into about 3 volts that this needs, and then being connected back to the ground, which completes the circuit. And that's how it lights up. All done
How
through the
does
Arduino microcontroller.
Like, how was it made?
What is it made? It's made out of different materials that when they connect to each other, they create that light. We can go into more detail. I know Polly is very interested in chemistry and the materials and all that. That's awesome. Very, very nice.
Gallium arsenide.
All right. So any questions from anyone? We'll go ahead and post this sketch, this program, so you can play with it. Next week, bring that up. Next week, we're going to try to do the pulse width modulation and let you guys see how we can control the dimness and so forth.
Question.
Yes, there's a question. Can you show the audience? Go ahead.
Rather not.
No, rather not. Okay, stay with me. Go ahead.
Is the next one at 6:15 or 7?
Is the next one what? Next week? It's going to be, let me take a look.
And it's in Orlando, it's not.
Yeah, the next one's going to be on the 2nd of February, and it's going to be in Orlando, at the Florida Mall. If anybody is interested in having total hands-on, please come. At the beginning, we'll do pulse width modulation, but I want to eventually get into joysticks and controlling motors. This is the same way they control motors as well. Very nice. Polly, think I found the resistor value that we needed.
But it's not that much.
Not that much?
Yeah, it's not.
Okay, go check it with the meter and tell me what it is, okay? Anyways, thank you very much. This has one more question?
No, just curious about checking ours out because we didn't have a laptop to drive the code.
Oh, okay. Well, bring it here.
Yeah. That's what
We have another one right here, and we can check it. Let me go ahead and unplug this. Meanwhile, we're checking it. I want to thank everybody for being here for the broadcast. Those that are watching at home, I'll post a link so you can see this video if you missed any part, and you'll be able to hopefully replicate what we've done today. Arduino is an amazing platform that we can use to create awesome things and to be able to do intelligent things. Eventually, we want to do a quad helicopter, an RC car, and slash rover from the ground up, and then later get into more medical field devices like the arms and be able to use servos and stuff like that. We also have a meetup, a workshop on home automation as well. So let me go ahead and send the code right here to you guys. And
What is that date again for the next meeting?
thank you.
Is this on? Is it on? It's on.
Now it's on. Okay, let me go ahead really quick and take a look and see if we put the right port here. Okay.